Hi, everybody. Welcome
Hi, guys.
to the next episode of Club, the community of experienced or not Cardano developers who are joining to discuss ongoing development of Scalus, but also discuss other topics, exchange ideas, share insights, and discuss how we can make the development experience on Cardano together. Today's session is dedicated to the work that we're doing on transaction building. And we'll be speaking about production transaction patterns with Scalus. Quick reminder for those who do not know, Scalus is a full stack development platform. Our aspiration is to have everything that you need to build on Cardano. So behind the Scalus brand, you have the ability to write Cardano smart contracts, build transactions, do other stuff off chain. But also you can leverage the GVM platform and all the solutions that exist for GVM to complement your business application. And also Scalus is used to support various scaling solutions like Hydrazone in Midgard. Since last time we presented 3 layers of Transaction Builder, and since then we decided to merge 2 of them. So low-level API and middle-layer API become one. It's called low-level API now. So right now you have 2 layers. One is, maybe Alex would like to explain.
Yeah, sure. So we have the low-level API based on intentions, or we call them transaction building steps, where you can define what would you like your transaction to have, like spend some UTXO, produce some outputs, stuff like that. And this is fully immutable and pure functional approach to transaction building. But it's reasonably low level, but you can do everything with it. And on top of that, we created this higher level API. Basically, it's a facade or DSL for this low level intentions based API. And today we're going to demonstrate that API.
Our session will be structured in a sequence of quick sessions of about 20 minutes. Each of them will start with some kind of context, followed by the demonstration of this or that capability. Then we reserve up to 10 minutes for us to discuss what is possible, what is not, what nice features or capabilities you would like to have, or maybe you would like to share some ideas or use cases so that we can learn from the real usage and improve and advance the platform. I will be facilitating this. We are trying to use the Q&A module that I will open once the demonstration will start. So instead of interrupting in the middle, we collect the questions, and then once the demonstration is over, I will just pick one by one, and then we will discuss those questions. So please don't hesitate to use this module in the chat. I will post the first question so that you will see how it works. Today's topic, Transaction Builder high-level API ergonomics, how you can do things fast, but also gain control when you need some specifics. Then there will be a section dedicated to interacting with smart contracts. Then some patterns that are useful for production applications. And at the end, we'll show the transaction chaining and our emulator provided that allows to emulate, accelerate your testing capabilities. And then we'll share some news about Scalus and what's next. Do you have any questions before we start? Yes, there was a Q&A module already. Matthew used one. All right, then I'll stop sharing, and Alex, you can share your screen and we can start.
Yes, let's go straight to the code. Our idea, our approach to transaction building is based on functional approach. We want to build transactions in a functional way with immutable data structures in a pure way if this is possible. So most of functions of Transaction Builder are pure functions. The only one which does effects is this complete thing. Let's start with a very simple example. We're going to build a simple transaction. If you're familiar with transaction building, you know that it's a tedious process because you need to set up fees, calculate execution budgets, collaterals, collateral returns, script data hashes, all that jazz, and we automate all of this. So we start with defining the transaction builder that takes an environment. Essentially, it's a Cardano environment in which we are building like mainnet or pre-prod and preview. And let's just send some 10 ADA to a pop. So we have a pop object that has an address and we pay to it. But for this transaction to happen, we also need to find money to pay. Also, we need to set up fees, handle change, all that stuff. And we have this beautiful magical function called complete that receives a provider that's going to query the UTXOs, find all the collateral inputs, all that's required to balance the transaction. And also we specify a sponsor who's going to pay for the transaction in terms of fees, collateral. And if we don't have enough inputs, provider is going to query this address as well. So this complete does everything. It returns a future. We wait for it. It's a synchronous API. It's not going to block. And then we just sign this transaction and we return a context from here so you can get a bunch of information from that context, but we are interested on the transaction here. And if we just print it, this body and witness, we can see that we are spending one input, that's Alice input. And we produce an output with data. And we produce the change to Alice. That's the change. And fees are automatically calculated. And everything is basically empty for this simple transaction. And we have a signature in the witnesses as well. So that's the way to build a simplest transaction. So this address obviously can be a script address. That's a simple payment transaction. What I wanted to mention here is that this call will produce a new updated transaction builder, which can be used essentially as a template. So you can reuse this object to do multiple payments, other parties. So this is essentially a template as well, because it's a beautiful, immutable object. Yeah, and complete, as I said, it sets the inputs from sponsor, finds collaterals, sends the collateral output if we need one, if we spend script addresses, calculates execution budgets using our script evaluator. So it does not send the transaction to Blockfrost or whatever. It calculates it very, very quickly on using Scalus, essentially. So it's going to calculate fees. Yeah, and handles change. Yeah. Next, I'm going to show you a more complicated example of a transaction building. That's going to involve, it's not going to use complete, where we're going to build our transaction purely functionally with no effects at all. So let me show you some helpers we can use for transaction building. This is the way to create a value that has a token. Here is a beacon token. And the policy ID is taken from this script. And this script is actually a very simple validator that we compile from Scala code. It just always returns unit, which is a always okay validator. So we use this script. This script hashes a policy ID and create this token. We support a value and coin arithmetic with values. We can create a value with 10 ADA, and then we can add a token to this value, and then we can remove those, and then the amount, if you take a look, is going to be 0. Same for coins. Coins is essentially a Lovelace value. So this is going to be 2 million. We can add some change, doing minus, plus operations. Also, we have a few helpers to create addresses. We have a Scala interpolator called adder. So you can place back 32 constants here. And same for the stake addresses as well. It's gonna throw in runtime if it's not the correct back 32, but otherwise you can use, it's very useful for constants. Also, we can produce more complex addresses with a lower level API. In this case, we produce so-called Franken address, where the payment and delegation parts are basically random. So currently, we just, for example, use the script hash for this address. So here we can specify that we want to spend this particular UTXO. For example, if we query one for somewhere that has a token or just a specific UTXO you want to spend, you can specify collaterals or references as well using this. You can specify the exact output, like precise output you want to receive. This is basically full control over output production. Specify address, value, data option, inline or hash or absent at all. And you can set up a script reference. This is the way to essentially deploy a smart contract, and then we can reference it and use it as a reference script or a reference data. Also, this is the way to specify metadata in a transaction. It's very straightforward. Just produce metadata type and put it here. Validity, we use standard Java types like instant. So now is instant no. And standard Java types for duration. So this is setting up the validity interval for this transaction. But also, we still manage to have the access to the low-level intention-based API. So you can add steps directly. These are the steps from last session, the low-level intentions. Here we set up a minimum fee we would like this transaction to have, and it's going to be 1 ADA. So if this transaction requires less fees, it's still going to be 1. If it requires more than 1, it's going to be more. So it's minimal. Here, we build this transaction and we specify that we want to, whatever change is left, we want to put it into the Alice's address. And this is pure and immutable operation. So yeah, it's not going to query anything. It's not going to block. It's a fast and simple operation. And we sign this transaction. And if we print it, we're going to see that it spans the UTXO we specified, and it produces a single output, because it finds this, that we created this output. So we have an output with the reference script. Here it is. And we have the change here. And we have a fee, which is 1 ADA, because that's minimal, and the actual fee was less than 1. And we have validity interval set up, auxiliary data hash. Yeah. And in witnesses, we've got the signature. Yeah, that's it. And the metadata is set up as well as we expected. Our idea is to provide a very simple and efficient API that is easy to use for common examples, but it's still powerful to do complex transactions or customized logic you would like. For example, we have a more generic build function that actually receives a diff handler. And diff handler is essentially a function from a diff, the change that is left, and transaction to a new transaction. That means that you can implement whatever logic of handling this change you would like. We have implemented the default one, which is going to find an address where you want to put the change to. But you can implement whatever you like. You can split between outputs. You can pay to treasury. You can donate to treasury. You can pay extra fees, whatever you like. So it's just a generic function. You do whatever you want. All right.
The idea was to show you the ergonomics of our high-level API, and what we're planning to do is to complement it with extra helper functions to simplify the use. And the question that we have for you, and this is just an open question, so if you have any examples or ideas, what type of helpers you would need to lack in other solutions for your day-to-day Cardano development. And while you are thinking about it, we will take a look into the question section. So there were two questions. First from Matthew. Do you want to take over?
I can ask the question.
Can you speak a bit louder because we barely hear you?
Sorry.
Yeah, much better.
One sec. I'm increasing my sound.
Yeah, amazing. Sounds great.
Okay. So yeah, I was wondering, so some of the dApps, when they use the providers like Blockfrost or others, they have no control about inside the transaction building loop, how many requests it's going to be doing. Like maybe they fell into a trap where some of the way the transaction is built, that we make a lot of small requests. So I was wondering if there is a way to control the number of requests that is done by the provider, like make sure, for example, you do the own requests on your own because you know what's going to be needed, and then the provider isn't allowed to make any requests anymore.
Absolutely. That's the idea. So the complete is like the first example that I show you. This complete, it does several queries, but if you don't use it, everything else does no queries at all. So you have absolutely full control over this. So we have this provider thing, and we have implementation of this provider called Emulator that we use in testing and transaction chaining and stuff like that. So this emulator essentially implements the provider. It has a like Blockfrost-like API. I'm going to show it a bit later here. But essentially, having this, and we have Blockfrost provider as well. And the idea with this full control API is that you can take this provider, emulator, and you find UTXO, blah, blah, blah. You can specify, find UTXOs which you like for collateral. For example, you can find UTXO for the reference, so you can find it manually by your own. You can take params, but in the Blockfrost, you can fetch vertical parameters and stuff like that. And then you can specify it here like this, essentially. And yeah, it's not going to query at all. Fully in your hands. Does it answer your question?
Yes, kind of. I'm not really looking for ways to customize everything in the transaction. Like, I like the fact that it's automatic. I like the fact that I can provide a set of things that are available, and the solver is still able to figure out what's useful in that set of available things without me having to picking that manually.
So you want to specify available UTXOs?
For example, yeah.
And it's going to select it, but not going to spend all of them, right?
Yes.
Yeah. Currently, we don't have this. You need to essentially make this logic outside and just provide. If you provide a spend here, it's going to require it to be spent. But we can implement this. We can.
I think
How
it's
it works, you name it, Alex, if you found the UTXO and then you use emulator, how it will work? Like every time emulator is running, it spans it?
maybe something like emulator where you can provide it to the emulator, not emulate data, but real data using the same logic.
That's actually going to work because emulator essentially receives the initial UTXOs, which you can query from whatever. And then you can pass the simulator to complete, and it's going to use only these things. So yeah, we can do this right now just with simulators.
Okay. Thanks.
I can add that you can just wrap provider request interface, and you can wrap provider by your own proxy. And if you just want to receive, then you can get a proxy and then or make external call or make local call.
I saw a comment from Giovanni. Yes, Scalus Transaction Builder does have this UTXO provider stuff, and is going to use it to query UTXOs for transaction evaluation. But it's more a blocks bin integration, blocks bin transaction builder integration. We wanted in our transaction builder to separate the effectful computations from pure computations. So yeah, but as Arslan mentioned, we can pass for example, block frost provider to the emulator, and it may redirect it to the block frost if it doesn't have enough information. Or you can pass this information to emulator yourself, and it's then complete is going to select whatever is needed using this cached data from emulator.
Provide some kind of examples and snippets about how to do it. There is a question from Lem Deck, if you want to voice it, or I can read it for you if you wish.
Hey everyone, am I audible?
Hey.
Yes. So the question is related to, let's say, a use case where I have a tab that's running on the browser. I would want to connect the wallet on the browser and then build a transaction, ideally on the backend, and then send it back to the client, get it signed by the wallet, and then I would want it to be submitted. So in that case, how is the flow? Can you just tell me what happens where?
Yes, currently this is a backend logic that this transaction builder happens on the backend. What we can do is we can build the transaction and not sign it here. Or if you just not sign it, it's going to be fine. It's still going to be a valid transaction. It's going to count for the required signers. So it's going to produce dummy signatures to correctly calculate the fees. So this is in our API. You can build a transaction that is signable and transferable. Then you can pass it to your front end to be signed. And then you can either submit it from your wallet or return it on the backend, and backend can send it to Blockfrost or whatever. But also our further development is, and our plan is to actually be able to export the transaction builder logic to JavaScript, because Scala compiles to JavaScript via ScalaJS. And all this logic can be exported to a JavaScript library, which you can then call from your front end, and it's going to produce you a transaction which you can sign with a wallet and send directly from your front end.
So it's our capability of all building full stack, the app. You continue writing everything in Scala, but just leverage our export to have exactly the same, but in JavaScript that you can later reuse on your front end.
Exactly. Essentially, you write a transaction builder logic once, and then you can share it on the back end and on the front end.
Yeah. I will put it down because we need to, we were going in the next iteration to work on our off-chain tool set. And this type of capabilities will be there, even though it's already possible. Just showcase it better and provide the documentation. There is the
I have just one follow-up question. So in the case where we're building the transaction on the backend, we still have to identify the UTXOs and collateral and so forth. What's the information that needs to be from the front end of the client to fetch all that?
So you're saying that you need information from the wallet on the backend, or what do you mean?
We've connected the wallet on the front end. Now we need to build a transaction. Now, assuming that we're building the transaction on the backend, we need to identify what are the UTXOs of that wallet and assets if needed. So the backend needs to have some information to identify what the wallet is, right? So what's the data or the object that's sent or need to be passed from the client to identify?
Yeah, you can receive the whole UTXO set from a wallet API, but that's not great. You can get the address of this wallet. You can pass it to a backend, and then backend could query the UTXOs just for this address. And we have an API for that. Find the UTXOs, and you can pass an address here. This you get from your wallet.
Yeah, so you don't need to interact with your front end to just get the address of your wallet while you're building transaction.
Mhm.
If you want to.
It would be something like that.
Okay, that sounds good. Thank you.
Cool. There is a question from Ken about delayed index redeemer. We'll show it a bit later.
I will show it a bit later.
I'll just park it for now. Perfect. Then there was a comment from Matthew. Yeah, there is a SIP 30. Yeah, I think we'll showcase, because this interaction back and front end, I think we'll need to showcase it separately. All right. Then let's go into the next topic, which is Transaction Builder interaction with smart contracts. Alex, your screen is not shared anymore.
Yeah, I thought you wanted us to show.
No, I don't have any.
Okay, no worries. All right, let's go to work with smart contracts. Let's build a smart contract transaction. First of all, let's take a look at a very common thing is deploying the smart contracts so we can use those as a reference scripts in our further transactions.
Sorry, Alex, before you start, maybe it's worth mentioning as well that Transaction Builder is not leading apart from smart contracts. In Scalus world, it's the decentralized application that you are building. So do you want to follow or?
Yeah, exactly. As Scalus is a integrated platform that allows you to do the full depths, we have implemented all the transaction logic and transaction serialization, deserialization, all the ledger domain objects, and we are able to compile Scala to smart contracts. We use the same data types across all these areas. This allows us to reuse a lot of code. This transaction output is the actual transaction output of a Cardano transaction. It's used in Transaction Builder and is used in smart contracts and everywhere. So we can reuse data types. So when we build a redeemer or a datum, it's the same data type that's going to be used in smart contracts and transactions. So in backend and on-chain code and even on front end. Yeah, so in order to build it, essentially this way we have an access to all our UTXOs. For example, Matthew, if you query UTXOs, available UTXOs to you, you can put it in an emulator, you can get access to those. You can select those as you like. So this is an example. We just take the first one and we say that we're going to want to spend it, and we produce a custom output where we put our reference script, which we're taken from compiled Scala code, but you can load it from Blueprint. So it's going to be written in A, can put part or whatever you like. So it's not like Scala only, obviously. And we build this transaction. So no queries to other services are here being made. So it's fully offline. So we don't need anything to query. Obviously, it's very fast. So we have this transaction and we can submit it in our emulator. And our emulator uses its local UTXO state. So it can track your updates, your transactions. And as we implemented Cardano Ledger rules, it's actually going to validate this transaction is correct against the Ledger rules. So it's going to fail if you're building something that's impossible to build. All right, so if we run this, for example, we'll see this transaction produces an output with our reference script. Also, a small nuance is that this transaction output goes to Alice. The address is Alice's address, and the change goes to Alice as well. The builder will find the same output and is going to produce only one output. So it's going to merge change into this output as well. So we have only one output, and it has the whatever 10 ADA plus all the change. It's not going to waste output. It's going to be smaller transaction. All right. So in witness again, we have a signature. Everything else is empty. And then let's try to mint a token. So we have our assets here. We just create a simple beacon token, NFT essentially. We can build an asset name from a string or from hex, just two variations. Let's build a minting transaction. So here we reference our script to not include the script into the transaction. We say that we're going to mint with this policy ID taken from the script our assets, and the redeemer is going to be a unit. The thing is, here we pass not the data, but the actual data type you want to use as a redeemer, and the transformation from it to data is going to happen automatically because Scala has this ability to find an implicit implementation of to data, essentially. So, and it's automatic. You can derive this like in Haskell. So you can say my data type derives from data into data, and it's going to automatically use it here. So that's very handy. So we're going to pay to Bob, and we expect to have this token here plus some ADA. We run complete using our emulator. So it's going to set up all the required other stuff. Let's see. So it spans the LSSDT and it produces an output with 2 ADA and this token. Here is our beacon token. And we see that this is the correctly calculated fees. We have a mint here. It's going to mint, so it's a special field in transaction body. We have a script data hash setup, collateral input setup, collateral return output setup. We set up a total collateral just to make sure everything is correct. And here our reference input from which the script is taken. Yeah, and the signature for the input. And here's our redeemer with calculated execution units. So we're minting. Yeah. So again, these are calculated using a validator. So no extra calling to some other services.
It's obviously supporting all script purposes in our transaction builder. So I'll quickly share my screen to show where you can find the documentation. So if you go on the Scalus website, you can quickly access the documentation and you have the extensive examples of how you can do spend actions, mint and burning. Obviously, we have all the staking, rewards, delegation capabilities, and as well the governance actions, delegating to stake pool, to DRAP, voting, becoming DRAP, etc. So, yeah, just use documentation. You can profit from the examples that are provided on our website. You continue, Alex, with applying parameters.
Yes. Sure. So essentially, we're going into more advanced stuff here. What usually happens is protocol will be parameterized. So you have an extra parameter that you apply before deploying your smart contract. In Scalus, it's done like this. So we have a script context as data. This is the actual smart contract, but we can say that this is a function from this config parameters that's going to return the validator. And if we compile it, we got a parameterized script that you see it receives an extra data parameter. What's cool about this thing, this parameterized validator, is this Plutus v3 class. It has the actual code as a field, and we can apply parameters to this code, and it's going to run on the JVM. So if we run this test in debug mode, it's going to set a breakpoint here, and set the breakpoint, we will get to the breakpoint here. So this, you see, it's essentially a constructor with 0 tag and empty arguments. But essentially, whatever you can write here, it's imported. But essentially, you get it. As you run it, it's going to show that I is 2. So you can debug your logic here and use it in tests. But also, you can get access to the program, which is a UPLC program. You can apply an argument using the $ operator, similar to how it's done in Haskell. So here we apply the config. And if we apply the script context, here I just pass unit, just for example, it's going to be fully applied program. And if we evaluate it using our implementation of CK machine, let's see what's going to happen. So it's going to say it's returning unit, and it's going to show you the budget, the fees of the execution, and it's going to show you what UPLC terms were executed and how many times, the memory, CPU, and fees taken for each of these types of UPLC terms, including built-ins. You can see which built-ins are taking how many steps or fees, which is very, very important for optimizing your smart contracts. It's very useful, very simple and very useful thing during the development. That's the applying parameters. Let's see, do we do the emulator here or in a separate session?
No, it's a bit later. Yeah, so yeah, this handy thing that we're maintaining the JVM, like a Java version of the program, so you can like rely on it to do the debug. And in the parallel, it's the equivalent that is executed in UTLC. So you're gaining all the capabilities of debugging and do like fancy stuff, and we're running them. So you can, like Alice showed, in debug mode, verify how it works, apply parameters, see what's going on in the transaction, the same interface. All right. Do you have any questions about this, about working with smart contracts? Go ahead.
Yeah, if the parameterization is available in Java as well, or is only Scalus?
Sorry?
Scala. If the script parameterization is available in Java as well, or is only
On the JVM? No, you need to compile this in Scala because we use the Scala plugin to essentially do the compilation. So this available only on Scala, but everything else, well, this functionality works on Java and Kotlin. We have this in Java. You don't have this operator, but we have something apply. So it's gonna do the same thing.
Yeah, because I'm doing a lot of it this, but I'm using, what's it called again? Eigen. And so I'm using the JNI.
Why? Switch to Scalus.
That's the last thing left in Eigen. And then I can do, once I switch this one, I can do everything natively as in JVM.
Hesitate, like guys, if you're doing some experiments with Scalus smart contracts, don't hesitate to ping us. We can make like some coding sessions together or support you in your development. Do not hesitate. We are
Absolutely.
looking for active users who wish to profit from our tool set. All right, there is a question from Kim. Do you want to voice it?
Hello, first.
Hey.
So my question, how would you go about applying parameters to UPLCs? If I understand correctly, there are two approaches you can take. You can either wrap the whole UPLC in a function and apply the parameter at the very end, or replace every occurrence of the parameter with the value itself. So I'm wondering which approach you have taken.
Good question. We've taken the first approach. So essentially, we produce this as a lambda with extra lambda, and then we just apply a parameter. So it's going to be apply lambda and argument. But as we have this applied theme, we can actually, with the three optimizer, what does it take? Essentially nothing. Optimizer, and we can do applied. Oh, right. Just a second. It's gonna take a turn. So we have an optimizer that has an inliner in it, and this inliner will inline a single usage constants. It does not have this extra lambda because it's gonna be inlined, essentially substituted and inlined. But if this, that's up to you. It's like an optimization step. If you want to do this, you do this, and it's gonna be awesome. But if you use this constant many times, it's a large constant. You don't want to inline it many times. So that's your decision. But if you use the optimizer, it's going to inline it for every. I think we do like 8 bytes. If it's less than 8 bytes, it's going to inline it everywhere.
Perfect. Thank you for your questions. Let's move to the section where we will show the indexed and delayed redeemers. Go ahead, Alex.
Yeah, so our goal is to provide a transaction that is immutable, ideally, and easy to use, but it's powerful to do the protocol level development where you need more customization. And one of the common use cases is actually what Phil described in his talk on recent UPLC conference, is that validators should not compute things. They should just validate that the witnesses or proofs are correct. So one of the common thing is that we need to find our own input in a script and our own continuation output, for example. And the usual approach is you get the inputs and you iterate through them and find the UTXO that is your own, and same for the output. But the more correct approach is actually to pass these indexes of inputs and outputs into a redeemer, into a script. So you can just validate that this input on this index is actually my own, and the output on this index is actually a continuation. It's a very common pattern. It's described in Anastasia Labs design patterns, and we have implemented it as well. It's called UTXO indexer. And the idea is very simple. So we have a data type indexer redeemer that contains the input index and output index. And our validator essentially uses this redeemer, gets inputs and outputs indexes from it, and validates that the inputs at this index is actually our own index, and the output this index is correct when we execute the actual validation logic. But the question is how to pass these inputs and outputs, because the problem is when we're building such a transaction, and we need to pass some other inputs, for example, to pay fees. And when you add those inputs, the thing in Cardano is that inputs are sorted by the transaction input. So the actual index may change while balancing the transaction. That's a very common problem, like every transaction builder probably faces it, and every protocol developer who tries to implement this indexing faces this problem. And I don't believe that, for example, Blockspin allows it easily to fix this problem. And the idea is that during the balancing, when you add the UTXOs, you need to essentially regenerate the redeemers. It's called delayed redeemers pattern, I believe. And we do support this thing. And it's done like that. So when we build in a transaction, we're spending a script. So this redeemer builder is run during the balancing loop. And you can do whatever logic you like. Usually, essentially, you go through inputs, find your own input, your own output, and just recreate the redeemer with the correct indices. So we support this for spans, for all types, essentially, for spans, for minting. It's not required for those because you're actually in control usually there. But in any case, it's a generalized API. So we have everything. Anything can regenerate redeemers based on current transaction during balancing.
Can you maybe share why it's useful and like why this pattern exists? Like, is it optimizing the cost or like what is like?
Yes, essentially the idea is instead of looking for these indices in script context, you just get the one from a redeemer and it's going to be cheaper. It's usually going to be significantly cheaper.
There is a question about Datum Builder.
We do not have datum builders because those are usually in your control. That's the redeemers that change.
That's not entirely accurate because some protocols like mine, like when a lender creates an offer, they have to cover the minimum UTXO value. So in the datum, that is, I call it an offer deposit. So the datum actually has to cover the minimum UTXO value exactly. So I have to recalculate the minimum UTXO again. I wind up doing like 3 separate passes until it stops changing or something. So it's like that's kind of where I was going. If you have the redeemer builder, can I also do something similar with the datum builder? It's just that one field for the minimum UTXO every single time.
Yeah, we can do this. We haven't done this yet, but yeah, we can do this as well. It's very simple.
Okay, cool. Any other questions? Yeah, there was Matthew, sorry. Go ahead.
Yeah. Do you have any ideas for how to standardize the most common use cases? Because having an escape hatch with a function is very useful because you can cover all the use cases. But there is one thing that is a drawback of this approach is that you cannot serialize the transaction building feature that contains a function. If it contains only data, you can serialize it. If it contains function, you cannot. So I was thinking of use cases where maybe people create templates of transaction building, like for example, something like TX3, where they have transaction building, which is based on templates. And in that situation, they need things that are represented by data and not function. So I was wondering, maybe there is a middle place where we can standardize some of the most common things, like finding the index of an input or thing like that. I don't know if you have thought about that use case.
Well, we didn't see the necessity for serializing this, so for us, having a function is all right. But having this standardized things like index builder actually is implemented as a template here because we have this build transaction logic and in indexed redeemer as an example that can be reused.
Yeah, I think my use case was, for example, imagine you want to build a website where people can build transactions, and dApps can provide like builders for their own transactions. Like I have a website which is transactionbuild.Cardano, and MinSwap comes or following car swap comes, and he provides a plugin that it's a template ready for his transactions, and maybe he needs access to the index of things inside his So he cannot provide it as data, he has to provide it as code instead because he needs to provide the function of the function that is retrieving the the inputs.
Some sort of a DSL or
Yeah.
Sky kind of algebra that we can interpret for some common use cases. No, not yet, but we believe that with our intention-based API, we can map TX3 to our builder relatively easily.
Okay.
All right, thank you for the questions. Let's go into transaction chaining and the emulator, the last topic of the session.
Yeah, it's going to be very simple. The idea is that we have this provider interface that allows you to query UTXOs. Yeah, that's primary goal. Essentially, think about it as a API for Blockfrost or Ogbios or whatever is needed to interact with a node. We have a testing implementation of it called Emulator that I described it to you. It already, essentially, it has a initial UTXOs, its state for Cardano Ledger, and has a list of validators. Those are Ledger rules. And list of mutators, those are rules that update Ledger state, change the UTXO, stuff like that. And this allows us to not only construct transactions, but also simulate their submission to a blockchain in case essentially updates the our local UTXO. And this allows us to produce sequences of transactions using this emulator. So here, for example, when we were building the smart contract transaction, we deployed a smart contract. We create a transaction that deploys a smart contract, and we submitted it into this emulator, and it updated the UTXO. So now it has this new UTXO. So now, if we're gonna query it, we actually could use it emulator, find UTXO to use the same API that we're gonna use to query Blockfrost, for example, or a node. And it's going to find it, and we're going to produce another transaction, and then we can query it, and we can produce another transaction. We can produce as many transactions, essentially a chain of transactions. This emulator essentially is a state handler. Yeah, this is our approach to transaction chaining. We don't even integrate because those are separate things, and they work quite nicely. Because we use it here as a provider to complete, it's going to query the latest UTXOs. This is how we can do transaction chaining. And also in tests, we can simulate passing of time. So we can set a particular slot. If you want to test that something happens after some timeout. Here's the example of an API, how to query UTXO, and here we can submit transaction. Yes, it's very, very simple interface. We use it for tests, yeah, and it can be used for transaction chaining as well.
Yeah, the cool feature about the emulator is that it's not only running and supporting the local state, but it also validates everything that goes on in your scripts that you are using, but also in your transaction against the Cardano Ledger rules. So we implemented all the rules except for governance and staking that allow us to basically run any transactions against this Ledger rule and make sure that it's working. And the advantage of this approach is that you can quickly switch between environments where you are running your transactions and scripts. So you can run the dev kit, which runs the actual node in your dev environment, and you can interact with it while building your transactions. You can use the testnet with the help of Blockfrost API. You can access the testnet. But all of those are relatively slow in comparison to the emulator provider. So by just changing provider to emulator, you're able to accelerate your testing and development cycle to something like a couple of milliseconds. I don't know, it's 87 milliseconds if you run the load test. But the execution of Ledger rules is just a couple of milliseconds. So if you put it into perspective, you can, when you're building your decentralized application, so you have your smart contracts, you have your transactions in the separate file, and then you can call your transactions from your test set, and you can construct a sequences of transactions. You can create like complex scenarios and stuff. And instead of waiting for minutes or at times hours to run the battery of the tests, you can run them against the emulator that will take maybe a couple of seconds, maybe 1 minute or whatever. So it's very suitable for acceleration of your development, integration, and test cycles. You can put it into your CI, and that will be still very fast. And you can, on other side, continue using the DevNet or pre-production or production to follow with the next stages of your development process. And this is essentially one of the motivations and goals of Scalus development platform, is to accelerate your development process, to bring everything together and connect it nicely so that you feel this ease of tools supporting you rather than frustration of something is running separately. You need to integrate, you need to wait for it to run. It takes a lot of time, so you are wasting your precious development time.
I just wanted to add that this approach allows you to have a transaction building code that you can use in production and in tests. And you can run tests using either emulator or SDF kit or pre-prod or mainnet if you want to test on mainnet. Using the same code, you don't need to change the code. You just change the provider from emulator to the Blockfrost or Ogmios. So the testing code is actually the same. So you just pass a different argument based on whatever environment variable or something. No, everything else is the same. That's a quite cool thing.
Yes, and the question that we had for you is what capabilities you think would be useful for us to add into our emulator or in our transaction builder testing infrastructure so that it's useful and helpful and reduces your time in development. So this is just a general question, and let's look into the question. Do you want to ask your questions?
Does that mean it doesn't track registration as well?
No, currently not. It validates that the registration certificate has correct deposit, but currently the state well, state checks everything else.
So then how do you execute a withdrawal script? Because I thought the ledger rules require that it's deposited. Like it has to be registered in order to execute withdrawal script. And then there are other cases where I have to deregister and something has to happen at the deregister step. So if it's not already registered, how can I deregister it?
Currently, emulator does not track it. We want to implement this staking state, but currently it's going to assume that it is correct and the real provider will fail, obviously.
So that would also work for deregistering? Like it's not keeping that state. Okay.
Yeah,
Yeah, and I allow you to deregister.
And you're referencing it because of the withdraw zero button?
That, but there's also like, I think Midgard, so maybe Kian can corroborate this, but if I want to mint a single token and I want to make sure that there's only one copy of existence of that token, I will require that the token is minted in the registration step. And then the only way to burn that is to deregister it. So I'm linking the two steps together.
Yes.
Yeah, we haven't done it yet, but we have implemented the staking state and the stake distribution calculation. So we have all this logic, but it's not implemented as a ledger rule yet. But we are very close, but it's not basically.
Yeah, we're iterating on the first group of rules that were required to support L2 development is the transaction rules. And this is a majority of the ledger rules to enable Hydrozo and then other L2 solutions development. So that will be just a natural step forward.
Yeah, probably in the next version because staking is relatively simple.
Okay. Yeah, I definitely don't need like delegation distributions like epoch boundary stuff. That all of that is not relevant. Also in the future with the account enhancements, where people start using the accounts more, it'll be useful.
Absolutely. We even have a state.
By the way, we had this idea as well because we want as well use, since it's relatively fast to prototype and build stuff in Scalus, to also supply Scalus as Scalus Ledger framework, as well as a playground for the SIP development. And just to illustrate this, we had the discussion with Alex about this account SIP that you are referencing. So right now you allow only withdraw everything, but by just modifying this ledger rule and providing the capabilities like deposing and partial retrieval, but also work with multi-asset, is relatively simple in our framework. So like we want to maybe pair with some of the SIP developers in the future to see if we can use a Scalus platform as a kind of prototyping environment for SIP development, because our Ledger framework is very easy to use in this regards. All rules are kind of extendable. You can deactivate, activate them and stuff. So it's kind of pretty neat. And also for for L2 developers, for developers who are building decentralized applications on L2s and want to build their own custom ledgers, this is the tool for it.
Yeah, it's really, it's much simpler and faster to prototype SIPs in Scalus. We are implementing the new built-ins and stuff for Plutus v4, and it takes just day or two. Yeah.
All right, Russ, you had the second question about script failures. Can you elaborate?
Yeah, so when it comes to composing intents together, some intents can't actually go together at like the smart contract level. For example, like my credit market, you can't be a borrower and a lender in the same transaction. So you can't create an ask and create an offer in the same transaction. So if somebody tries to build that, the smart contract should fail and say like, hey, you can't be both. So is there a way to, like, when I'm testing the smart contracts, I want to make sure it actually fails with the correct error message. So that's my kind of my question.
Yeah, I give it a bit like a bit broader answer. So one of the things that we're using in Scalus in testing smart contracts is that we allow to, essentially, we want to test smart contracts with real transactions. So what we allow is to, you build a transaction, you run it, and the smart contract gonna produce an error, and you can catch it, and you can validate like logs, for example. You can search certain log and stuff like that. Also, you can test your scripts obviously with on the JVM. You can expect certain exceptions, for example. But like in this case you're describing, when you run multiple validators, right? So the ideal testing situation would be to build a transaction, run it, and it's gonna fail. In emulator is gonna be failing during the build process that runs the script evaluator. And then you'll receive an exception and you can catch it and verify against it. We use this approach in our smart contract testing, basically. I'll see probably tests, whereas those still state test. I believe here we have an example like that. So we have an emulator, and let's show the test fails with run pre-image. So we build a transaction and submit, and reveal, and here we expect it's a failure, and log contains whatever message we expect it to have. So yes, it's possible, and it's relatively easy.
All right, there are no more questions. Thank you for the participation. I will share my screen to share some news about what's going on. First of all, we're preparing the new release. It will be the last release in this year, release 0.14. So we're having the production-ready transaction builder, low-level and high-level API, transaction chaining, delayed redeemers, helpers, commonly used providers. We have also updated our website. So we have updated our documentation. You can find the onboarding guides for Cardano developers, but also for Scala developers, where you have the videos of how to start with Scalus. We provided for the smart contracts development language guide, so you can go see the examples. I just added a lot of examples so that you can always find an answer in the documentation. Control flow, functions, how to build modules and stuff. Useful thing, supported features, like some features were from Scala that are not available. We're updating it every time we add new capabilities. For smart contracts development, you have examples. So we have this validator, you have step-by-step guides, how to do it, and then some insights, how to test, debug, and compile smart contracts. Transaction Builder were already referenced, and then there is a learning session where you can learn about different vulnerabilities and design patterns. So feel free to take a look. We are also finalizing the work about Ledger rules framework. So we will be providing those for the L2 and the apps developers. We are finalizing as well the conformance and smoke testing. So those rules are validated against the golden tests that other node implementers are using. And yeah, it's a blazing fast test environment for your applications. What's next? We're actively developing the update for built-ins and other capabilities like scalar multiplications that will be delivered in protocol 11 in next hard fork. So probably in January, the hard fork will be released and will be ready in the beginning of the year. The work already has progressed. We have already like half of built-ins implemented. We started working with our partners to implement our Scalus off-chain tools, notably strict evaluator and cost calculations into various transaction builders. For example, we will be working with Mesh.js to help them supplement a collection of script evaluation tools. Many developers are using JavaScript libraries like Lucid Evolution or Evolution SDK and Mesh. And under the hood of those libraries are using either Aiken, UPLC, or CML, Rust, Net modules. So Scalus provides native JavaScript functions for this. So we will be helping our partners to integrate those tools. So this is something that is coming in the beginning of the year. We also feed in our smart contracts library with use cases. Right now we have, I think, 7 or 8 out of 21. In January, we'll have 7 extra. So you can find examples of HTLC, escrow, returns, other spin and splitter, baiting, what else, Vault, and other stuff. So if you want to find examples of smart contracts, you can go to the examples directory of Scalus repository and see those smart contracts. Will be communicating about this as well. We're also updating our starter kit. Our goal is to provide the example of the app that anyone can download and see how to build the app using Scalus. Our starter kit will include examples of smart contracts, examples of transaction build and testing capabilities, but also the simple server and simple front end so that anybody can start very easily and run the app from the get-go. And we'll be hosting the next session in approximately in a month. So if you want to learn something about Scalus or see if this or that capability exists, you don't hesitate to ping us and request any type of showcase or demo. Also, if you have any ideas how we can make Scalus better, don't hesitate to join our Discord or hit us on Twitter. Thank you, and have a nice end of the year.
Merry Christmas.
Happy holidays. Bye, and thank you.
Thank you. Bye.
Thank you.